Hello and welcome to this video. I am Karnesh Johri and this video is about grep command in Linux. The grep command is about searching strings in files. So if you have a file named try and you wish to find string sir in this file, you can give the command grep quotes sir quotes closed try, and grep gives a list of lines containing the string sir. Actually, it is more than strings. It is about regular expressions. The command syntax is grep options patterns files. The files are optional. If you do not specify files, standard input is assumed. Grep writes on standard output. It is a filter which reads input, does processing, and writes on standard output. The patterns are regular expressions, and this leads to the important question: what are regular expressions? Regular expressions are used to specify search patterns for strings in text. A regular expression is a sequence of characters, and some characters in a regular expression can be meta characters which have a special meaning, so that a regular expression using these meta characters can match multiple classes of strings in text. There are three types of regular expressions. First, basic regular expressions, then extended regular expressions, and lastly, Perl compatible regular expressions. In some implementations, basic regular expressions are available which are somewhat weaker than the extended regular expressions. In GNU grep, there is no difference in functionality between the basic and extended regular expressions. Only the syntax is different. You have to use "-e option for extended regular expressions. For Perl compatible regular expressions, "-p option is to be used and PCRE library needs to be installed. What do regular expressions comprise of? The fundamental building block in regular expression is a single character. Most characters are regular expression and match themselves except for special characters. To match special characters, escape it with a backslash and the special character is matched. Then there are anchors. Caret anchors a regular expression to the beginning of a line. Similarly, $anchors a regular expression to the end of a line. Dot matches any single character. Then we have characters inside brackets. Inside brackets, it is simply a list of characters inside brackets like ABCD or PQRS1234. It matches any single character inside the brackets. If the first character inside brackets is caret, then it matches any single character not in the brackets. Now we can specify a range like brackets A-D, which is equivalent to brackets ABCD. Here we need to specify the locale as C, then only brackets A-D will be equivalent to brackets ABCD. Some locales sort characters in dictionary order, and in some of those cases, brackets A-D might mean brackets lowercase a, uppercase b, lowercase b, uppercase c, lowercase c, uppercase d, followed by lowercase d, which is not what is normally meant. So to make things unambiguous, it is better to set the environment variable lc_all to the value c to get C locale. Then there are predefined classes which match any character which is part of the class. These classes are enclosed inside double brackets and have colon before and after the class name. So lower is for lowercase characters. For lower matches any of the lowercase letters, whereas upper matches any of the uppercase letters. In all these cases, it is assumed that the locale is set to C. Alpha matches any of the alphabetic characters and digit matches any one of the digits 0 to 9. ALNUM matches any of the alphanumeric characters, that is, union of alpha and digit. PUNCT matches any of the punctuation characters. Graph matches any of the graphical characters, union of alphanumeric and punctuation. Space matches any of the space character like tab, new line, vertical tab, form feed, carriage return, and space. Print matches any of the printable characters, which is union of graph and space. Blank matches one of the blank characters, space and tab. CNTRL control any of the control characters for ASCII, octal 0 through octal 037 and octal 177. X digit matches any one of the hexadecimal digits 0 to 9 and A to F. And as I said earlier, inside brackets, if you put caret as the first character, any character not inside the bracket is matched. Then we have repetition. R star, R is matched 0 or more times. R plus, R is matched 1 or more times. And this is for extended regular expressions. R question mark, R is matched 0 or 1 time. R n in braces, R is matched exactly n times. R braces n comma, R is matched at least n times. R braces comma m, R is matched at most m times. R braces n comma m, R is matched at least n times but not more than m times. Then we have concatenation. R1, R2, R1 followed by R2 are matched. Then we have alternation. R1 pipe R2, either R1 or R2 is matched. And then R inside parenthesis. As per the precedence, repetition has the highest precedence, followed by concatenation, and alternation has the least precedence. Suppose you want to have concatenation like R1, R2, you can put it inside parenthesis and have repetition of that. So whatever inside parenthesis is matched, and this can be nested. And why it is named grep? Grep is influenced by the original Unix text editor ed. ed, sed and grep were early implementations of regular expressions. ed was a line editor. It operated on lines of text in files. ed has a global command G followed by regular expression between two slashes followed by a command list. The global command finds all lines matching the regular expression. And for these lines, the commands after slash are executed. If the command after slash is P, ed prints all lines of text matching the regular expression. And that is what grep does. Now we look at options for the grep command, and the first option is -e or --, extended -regex. This essentially means that the patterns are to be interpreted as extended regular expressions. I have a C source file here, and I want to know about the lines where uppercase CC occurs multiple times. So I can say grep quote parenthesis CC star quote temp file. This does not work because parenthesis for extended regular expressions only. So we can say grep -e quote parenthesis CC star quote temp file, and we get a lot of output because it matches CC 0 or more times. A better regular expression would be CC in parenthesis plus, and we get the lines where CC occurs 1 or more times. -i or --, ignore case, is for case-insensitive search. That is, the characters in pattern are matched regardless of the case in pattern or input files. So for example, you wish to find the string word in either case in the file dictionary.c, we can give the command grep -I "word" dictionary.c pipe to head for the first 10 matches. The next option is -e patterns or --regexp equal to patterns. With this option we can pass patterns to grep, and we can use this option multiple times. Notice the plural patterns. With a single -e option, you can pass multiple patterns. These patterns have to be separated by new lines. For example, grep -e string, new line, word, -e bool, new line, main, new line include, dictionary.c, and we get this output which includes all the patterns. Instead of passing patterns on the command line, we can put the patterns in a file, one per line, and pass the file with -f or file equal to file option. For example, we can put patterns, string, word and bool in file f1 and pass it to grep as in grep -f f1 dictionary.c and get this output with lines matching the patterns. We can use the -f option multiple times, and we can mix -e and -f options. -n or line number option prints the line numbers along with the matched line. This can be useful when you do not know the exact spelling of the term you are searching for, or the term is little big and you know a substring in it, so you can search for the substring, scan the results, find the line number of the line containing the exact string, and go to it in the editor. Then -v or -1s invert match inverts the sense of matching. It prints the lines which do not match the patterns. The option -w or -word regexp prints the lines where pattern matches the whole word. For example, in this file, the string ptr is in so many places. If you want to find the lines with ptr as a word and not a substring of another word, you can say grep -w ptr dictionary.c, and you can get lines that have ptr as a whole word. Here, a word is delimited by either beginning of the line or end of the line or a character other than a letter of alphabet, a number, or an underscore. That is, a word comprises of only letters, digits, and underscore. Anything other than that delimits a word. Next, the -x or line regex option. This means the pattern must match the entire line, then only it is printed as a match. You can get the same result without the -x option by enclosing the pattern between caret and dollar. Lastly, we have two options, -l or files with matches and -l or files without matches. When you use either of them, the normal output is suppressed, and in case of l, it prints the names of files which have lines that match the patterns, and in case of L, it prints the names of files which do not contain lines that match the patterns. And we come to the end of this video. You can find all this information at https://tiny.1/grep-command. Please subscribe to SoftPrayog for software related videos. Thanks very much for watching. Take care and stay safe.